Hello, welcome to Homework Help, the Algonquin Area Public Library's volunteer-run homework help video series for all ages. I am Valentine Stephanie, and I'm going to teach you about chemical equations today. Okay, so before we start, I'm just going to give you a little bit of background information, just some vocabulary that I might use in the video before we start. So firstly, looking at this chemical equation or chemical reaction, I want to teach you the reactants and the products. So the reactants will always be on the left side of our equation. They're what we call the starting substances. So in this situation, it would just be the hydrogen plus the oxygen. Those would be our reactants. And on the other side, the right side, our resulting substances are called our products. Okay, so then we have something called subscripts. They're written in red here, here, and here. So these are the number of atoms in the formula. You never want to change those. Just keep it a reminder, wrote it in red, you don't want to change those. And then for our coefficients, so that would be like these, those are in front of the substances and you multiply these coefficients. You multiply them by the subscripts. So for this hydrogen, we would multiply 2 by 2 to have 4. And then if you look on this side, 2 times 2 equals 4. I just want to say, this line is not an equal sign. It's more of like a produces sign, it reacts to form sign, just to let you guys know. Okay, so let's start with the types of reactions. We have synthesis, decomposition, single replacement, double replacement, and combustion. So starting with synthesis, it's a reaction that forms one neutral ionic product containing the elements in the reactants. So an example of this would be like hydrogen plus chlorine equaling 2 hydrogen chloride. Simple as that. We're just putting the elements in the reactants together to form this one neutral ionic product. Next, decomposition is kind of like the exact opposite with that. We're going to break it down into its components. So let's just use the same example. And ultimately, we're just going to break it down into the same elements that were in the reactants here. So we would have hydrogen plus chlorine. Now, for single replacement, but sometimes displacement, we're going to swap out the cation or anion in a compound for a single element. I'll show you what that means. Let's just say we had iron plus copper sulfate. That would equal copper plus iron sulfate. Basically, this iron right here switched places with this copper. So now copper is on its own the same way iron was, and now iron has become iron sulfate. So for double replacement, we're now going to swap out both cations or anions to form two neutral products. So let's just say we had silver nitrate plus potassium chloride. That would form silver chloride plus potassium nitrate. Similarly to what we did before, they're kind of switching partners in this case. This right here, silver, used to be with nitrate, but now it's switched, so it's with chlorine, or now it's silver chloride. Same thing, the potassium used to be with chlorine, but now it's with the nitrate. Finally, for combustion, we're going to add heat to oxygen and another molecule to produce carbon dioxide or CO2 and water. So it should look something like this. You need to have a carbon and a hydrogen in your molecule, but you'll have to add oxygen in order to form CO2 and HO2. Okay, so now we're going to solve. When solving a chemical equations, you have to keep everything equal. If you have 2 carbon atoms on the left side, on the reactant side, you have to have 2 on the other. So in order to do this, I actually like writing it out. So here we have CH4 plus oxygen is going to react to form CO2, which is carbon dioxide, plus H2O, water. So I like to write out whatever the element name is, and then the number of atoms we have. Sometimes you can even do whole molecules, but for this specific one, I'm just going to do them by element. So for carbon, we just have 1. Here it is. For hydrogen, we have 4. Don't forget to read the subscripts. And then for oxygen, we have 2. Then on our other side, for carbon, I like to just keep the same elements on the same line. So for carbon, we also have 1. Hydrogen, we have 2. And then oxygen, we have 3. You always have to make sure that you're counting, even if they're in different substances, or, I apologize, molecules. So now we need to keep them even. So just looking at it, our carbons are even. That's great. We're not even going to start with carbons. I think we should start with hydrogen. So we have 2 hydrogens on the product side, but 4 on the reactant side. So we need to do some multiplication. Well, 2 times 2 is 4, so we're just going to put a 2 right in front of this H2O. So now, instead, we have 4 hydrogens. Great. And now if you multiply, we have 6 oxygens, but you also have to add it to this side. So now we have 4 oxygens. Okay, great. Now, looking at the other side, we have everything set except for the oxygen. Everything is equal. We just have to fix this oxygen. Well, we know that 2 times 2 equals 4, so we just put a 2 right in front of this O2, and then everything is equal. So notice that we have 2 empty places in front of the CH4 and CO2. Since we didn't put a coefficient there, we can just put a 1, and now your chemical equation is solved. Okay, so now we have what looks like a more difficult chemical equation. We have silver nitrate plus magnesium chloride equaling or forming, reacting to form, silver chloride and magnesium nitrate. So, looks kind of difficult. This is actually an example of double replacement. But what's nice about double replacement is that we can use the whole molecules when solving. So I'm just going to do what I did last time and start listing out the elements. Ag silver, we've got 1. And I'm actually just going to use NO3 nitrate as just, I'm going to pretend like it's 1 element to make it easier. We've also got 1, magnesium 1, chlorine 2. Same thing on the other side. So when you stumble upon this, you have to remember that this is something separate, okay? So we're just going to multiply the 2 for this nitrate. So we have 2, magnesium 1, and chlorine 1. Okay, well, let's just start using basic math and start solving. So I see that we have uneven molecule or number of molecules of nitrate. So we're just going to do some multiplication on the reactant side. Let's add a 2. So this becomes 2, this becomes 2. So great, our nitrates are even, but now our silver isn't. So I'm going to add a 2 here so we can have 2 on this side. Great, silver is equal, but we also have to remember that we have to multiply chlorine by 2. Well, great, the other side actually had a 2 for chlorine too. So now it is solved. And just remember, if you don't use any coefficient in front of something, just put a 1. Great. Thank you for joining us on Homework Help today. If you have any video suggestions or are a teen who would like to earn volunteer hours by recording a video for us, please email Lindsay at teen@applid.org.